Thank you for joining us here at Alberta Lake Management Society with our Winter Lakekeepers program. Here we will show you step by step how you will successfully sample your sites this year. Again, thank you for your interest and passion in participating in our Lakekeepers program this year. With your assistance, we are able to collect water quality data that allows us to fill gaps that exist in many parts of Alberta, and in part helps us to promote understanding and comprehensive management of lakes and reservoirs in their watersheds. We appreciate all your help. In this video, we will walk you through the key steps of sampling, safety, and data collection protocols. It's important to follow these steps consistently to ensure the data collected is accurate, reliable, and usable for future projects or to help address community concerns. We also have a summer program, so if you're interested in that, you can check that out at alms.ca. Look for Summer Lakekeepers program. Before you head out to sample, you will need to make sure that you have all your proper gear ready to sample. ALMS will supply you with most of the things you will need in order to sample. This includes a probe kit, a chlorophyll kit, bottle sets, a tape and weight, an ice measuring stick, insulated gloves, a hot water bottle, and field sheets and your field manual. A few things that ALMS does not provide is an ice auger to make your holes, the ice scoops and shovels to clean the hole in the area, and your ice safety gear. This list will also be included in your field manual, so please be sure to read that over before going out. There are a few things that you will want to do before you head out to sample. First, you want to make sure that you fill your hot water bottle with hot water before leaving to sample and putting it in your probe kit. This will help keep the probe warm and prevent any damage from cold weather. Then you will make sure that your probe is charged. You will look into the top right-hand corner and it'll tell you what the battery percent is at. So make sure that that is charged up before you head out. Next, you will want to check the weather on any app that you typically use. You will want to make sure that you are sampling in weather that is no colder than minus 20 degrees, and that's including the wind chill. This will help you to stay safe and to be able to collect accurate data, and it also prevents damage to the equipment. Next, we will want to calibrate the dissolved oxygen and conductivity, which we will go into in a little bit here. The ALM staff will let you know what parameters you will need to calibrate. Next, you'll want to make sure that you freeze ice packs the night before so that you can add them to your cooler before you head out. Also let the ALMS staff know so we will know when you're sampling so we can be ready to collect your samples after you have shipped them to us. Next, you want to prep your transportation with field gear and safety gear. We'll also mention to keep in mind if you are using an ATV to get out onto the lake, ensure you have enough gas, safety gear, and that everything can be secured on the way to the water body and on the way back. And if you have to travel farther to your water body, that you have enough cold ice packs to keep the samples cold. So to pack up your field gear to take out sampling, you won't need to take everything that we send you. In your packing list, you will need to make sure that you have your field manual and your field sheet. With the field sheet, make sure that it's the correct field sheet, that it says Winter Lakekeepers and not Summer. Then you will make sure you bring your tape and weight, the ice measuring stick, the YSI probe and handheld in the kit, with the hot water bottle, your long green insulated gloves, the cooler with the cold ice packs that include your sample bottles, an ice auger, the ice scoop, and a shovel. Now it's time to go over calibration. We'll start by attaching the probe cord to the handheld and turning on the handheld, removing the gray sleeve and then the metal covering. Be careful when you are removing it that you don't nick the end of the probe or hit the sensors. And we will take a Kim wipe that's in your kit and dab the probe tip on and around, just making sure there's no moisture. And then we will inspect the probe sensor to make sure that there's no nicks or bumps or anything like that. Once we've inspected it, we can put the metal guard back on carefully and screw it back on till it's tight. And in the gray sleeve will be a yellow sponge that we'll make sure is in there, and we will put some pure water. You don't need a lot, just a little bit, just to wet the sponge. So once that's on, we will put the gray sleeve back on and stand the probe upright while we begin to calibrate. Allow your probe to stand for about a minute just to allow the probe to acclimate to the moisture from the wet sponge. We will begin with dissolved oxygen calibration, so you'll hit the calibration button and look for ODO, click enter, then DO %, enter, and it'll come up with this screen, and you'll see that there is a barometer value with some numbers, and we're wanting to take note of what's written there, so we'll write that down on our field sheet. And as it's calibrating, we'll see the lines go across the screen, and we want to make sure that there's no dips or spikes in the lines, just to make sure that it is stable. And once we're confident it is stable, we will accept this calibration. So we'll highlight that and press enter, and you'll see calibrating sensor, and it was successful. With this, you'll know that you've done it correctly and you're ready to go on to connectivity. So you will take your calibration solution that will be in your kit and take note of these numbers because we will use them later, and your graduated cylinder. And we will take our probe and take the gray sleeve off, leaving the metal covering on for this one. And we will fill the graduated cylinder with the calibration solution. And we want to fill it so that it's halfway full, and then we will put our probe in the cylinder. And so we see here, this is the calibration sensor. We want to make sure that that is completely submerged in the calibration solution. So when you put it in, if it's not completely full, we'll just top it up so that that sensor is covered. And we'll flick it so that if there's any air bubbles that they will escape. We will let this sit for about a minute to acclimate to the solution. Once that's completed and we're making sure that there's no air bubbles, we will go to our handheld and press calibration, this time looking for conductivity, enter. We'll click on specific conductance, and then we will be at our screen again, and we will click on the calibration value, and we're going to change that to those numbers that are written on the calibration solution bottle. So for here, it's 979. We'll enter, and then we'll see that calibration is beginning. We're seeing those lines go across, and we will let that sit for about a minute. And we'll watch those lines, making sure there's no spikes and no bumps so that it's stable. And after a few minutes of making sure that that's stable, we will click accept calibration. We'll see again that it'll say calibrating sensor and calibration successful. We will then return to our main screen. And here we will go through our values that we will be looking for. So we will have our temperature that is measured in Celsius, our dissolved oxygen that's measured in milligrams per liter, and our conductivity that's measured in microsiemens per centimeter. Most of our ALMS probes do measure all three parameters now. However, there are a few that only measure temperature and dissolved oxygen still, and will only display these on the screen. An ALMS staff member will let you know what your probe is capable of measuring. Once you are packed and ready to go, you are ready to head out and sample. We encourage you to choose your sample site that is either at the deepest known part of the lake or an area of concern. If you need assistance on choosing a site, contact our staff at ALMS and we can help you out. Before you head out on the ice, you want to make sure that the ice is thick enough to safely sample. You can refer to the ice thickness chart for guidelines of what kind of vehicle is safe, and you can also make small holes in the ice or drill small holes to see the ice thickness when you're close to the shore, and then make another hole or test hole about 150 feet apart, so then you can see if there's any unsafe spots. If you want to review some safety guidelines, we do have a safety guide on our ALMS page that we will include the link below. This will also include our ice safety gear list that if you wanted to review that as well before heading out, you can do so as well. Since many of you will be sampling more than once this season, we do encourage that you choose the same sample site location as the previous site visit. When you are choosing a site, please do not choose a site that is close to the shoreline. The deeper the location, the more robust the data that is collected will be. There are a few things you need to do once you arrive at your profile site. First, if you have driven out on the lake using ATV or a vehicle, you will have to turn your vehicle off to prevent any contaminants getting into the samples. You will then auger 2 separate holes, one for collecting the data using the probe, and then the other to collect the water samples into the bottles. Once these holes are made, you will want to use your ice scoop and shovel to clear the area and then to clear out the hole. And you want to make sure that you get as much of that ice out as possible so it doesn't get into our samples. Once your holes are made, you can start filling out your field sheet, and on the field sheet you will write down your sample coordinates. So the coordinates you can get from your phone through any app that you may use like Google Maps. For filling out the field sheet, we will go over that in a little bit, how we do so. And you will also want to label your bottle sets, which we will show later on as well. We'll start by filling out our field sheet. So here we will include our lake name and also the location name. Your location names are reference points on the lake that aid in identifying the sampling location, like a boat launch or north or south basin, anything like that. We will write down the date and the time, as well as the kit number that is written on the side of your probe kit. And then you will include all who are helping with sampling. So all the volunteer names will go under the volunteer or monitor names. There is also a section here to fill out the hours spent sampling. It is important to fill this out before shipping or dropping off your samples at the ALMS office. This helps us keep track of all the help that we get throughout the years from partners like yourself. This includes things like your time it takes you to calibrate, driving, the time it takes to sample, and also if you have to filter. As you're filling out your field sheet, you will want to measure the bottom depth of the lake where you are sampling. So you will take your tape and weight and you will lower it down through the hole until you can feel some slack that it's hit the bottom. Once you feel it hit the bottom, you will note where the top of the water is with the measurements, and you will jot this down in the bottom depth section on the back of your field sheet. Make sure that you also measure in meters and not in feet. Next, you will want to take your ice measuring stick and extend it out. You will want to measure the depth of the snow that's on top of the ice for your snow thickness. Then you will put the ice measuring stick down into the hole. You will measure the total thickness of the ice, and you will write that down in the ice thickness section. Next, you'll want to measure white ice thickness. So white ice is formed when snow melts and refreezes, and this can happen during warm spells or rain events, or even if the snow layer is heavy enough to force water up through cracks in the ice. When you're measuring this, you will look for where the ice is white in the total ice thickness. Sometimes there's nothing at all, but we will take note of that wherever you see it. There is a good description and example in your field manual, so please make sure to take a look at that before heading out. And you will measure and write that on your field sheet. It is important to measure your snow and ice thickness in centimeters only. Once you have that filled out, you can go on to fill out the rest of the environmental observations on your field sheet. So we'll start with our snow coverage. So you will look out on the lake and determine what kind of coverage there is, if it's completely covered by snow or partially covered by snow, or that there's just drifts, or if it's been warm, if there's standing water or any slush presence. You will also look at your phone to get your air temperature in Celsius, and then you will look into the holes that you created and determine the color of the water, that being colorless, brown, green, or any other kind of color. You can write that down. And then also the water clarity. So if it's cloudy or if it's turbid, anything like that, just describe it in this section. And then you'll also see if there's an odor present and write that down accordingly. On the backside, there's also a section for additional comments, like if there was difficulty accessing the lake, if there is any observed lake level changes or issues with equipment, or anything of note that was different than what you typically see for water quality, then this is the section you'll want to add that in. Next, we will get our probe ready to take our probe measurements. It is important to note when you are working with your probe and handheld to make sure that the probe and handheld stays off the ice and inside the probe kit, and to keep it closed with that hot water bottle. This will prevent any damage to the probe. So we will remove the gray sleeve and lower it in so that the connectivity sensor is just below the surface of the water. This is our marking guide that's taped on the probe. So you can find this in your field manual to refer back to it. But each color marking represents a different measurement on the probe. So we'll have in the blue, this is found right on the main part of the probe sensor at 0.1 for your first reading, and then a second marking in pink at 0.5. Then we have our orange tape, which represents 1 meter. So this will be marked as we will be taking measurements at every 1 meter after those first two measurements. For the 5 meter, the 15 meter, and the 25 meter measurement, we will have it marked with pink and orange. And for our 10 meter and 20 meter and 30 meter marking, we will have that marked as blue and orange. So again, you can refer back to this in your field manual if you need further clarification. We will go to our handheld, and on our main screen will be our readings. When you first put it in the water, wait a couple minutes for the values to stabilize and stop rapidly changing. It's likely the DO will never stop moving completely, so wait till it has slowed down significantly and use your judgment to record the reading on your field sheet. Once your numbers have stabilized, we can jot down the values that we are reading at that point. So in this case, we're doing our first reading, which is at 0.1 meters. So we will take the values of the temperature, the dissolved oxygen, and the conductivity, and then you will lower it to the 0.5 meters marked in pink. Once those are done, we will move it down to the 1 meter marks, which are marked in orange. And you will take depths at every meter after this until you reach about a meter or a half meter from the bottom. So in our case here, our bottom depth is 8.3 meters. So we are going to go down to 8 meters and we'll stop taking measurements at the 8-meter mark. For another example, if you measure your bottom depth at 5.1 to 5.9, you would then want to measure up to 5 meters. But if you measure your bottom depth at exactly 5.0 meters, then you would want to measure at 4 meters, just so you don't hit bottom in your measurements. This is why it's very important to measure your bottom depth in meters only and not in feet. It just makes this part easier to calculate up to what meter you will be measuring to. When you hit the bottom, you do not need to record a depth reading here. All your values will be thrown off due to the sediment, so we do not need to record when we hit the bottom. Now we can move on to our bottle set. We will make sure to label our bottles before we put them in the water. It is easier to write on them when they are not wet. So we'll put the name of the lake, location, the date, and also the time. Make sure all your bottles have the exact same time and that they match your field sheet. So the time you write on one, you're going to write the same on all of them. It is important to ensure that your samples are labeled so that there isn't a chance for them to get mixed up with other samples coming into the office. Since you took your probe measurements in one hole, you will take your bottle samples in the other hole that you have created. This helps to prevent disturbance or contamination of water being sampled. We have different protocols within the program to offer better support and flexibility for our volunteers, depending on your schedule and experience level. Before beginning, please confirm with ALMS which protocol you'll be following, or reach out to us if you'd like help determining which one of these fit best for you. It's very important to always refer to your field manual each season, as bottle sets may change and updates to protocols will always be reflected there. Now let's start with the P1 protocol. This protocol includes a small bottle set that is either preserved or shelf stable, allowing for longer hold times and more flexibility. Perfect if your schedule is busy or if you live far from a Purolator drop-off location and can't return the samples within 3 days. Make sure to include a frozen ice pack in your P1 bottle set prior to leaving for site. Please wear the provided insulated gloves to keep your hands warm while collecting samples. There are also nitrile gloves in your probe kit that you or your sampling partner can wear when adding the appropriate preservatives to the bottles. Each preservative will be attached to the relevant bottle. Before sampling, remove the preservative and set aside while you fill the bottle. This prevents it from accidentally falling into the lake. These bottles do not need to be triple rinsed. Simply fill them directly in the lake as far as you can comfortably reach without getting your gloves full of water. If you can't ship or drop off your samples right away, store them in the fridge to keep cold. Do not freeze them. For the P1 protocol, all samples must be submitted back to ALMS within 2 weeks of collection to ensure accurate analysis within laboratory hold times. We often recommend that new volunteers start with the P1 protocol until they feel confident in our methods and sampling procedures. Now let's talk about P2 protocol. This protocol includes more bottles to collect, including a chlorophyll A bottle, and is designed for volunteers who are comfortable with a more complex bottle set and can accommodate a more strict sample schedule. Just like in P1, include a frozen ice pack in the cooler prior to leaving, and please use the provided gloves to fill your bottle. For example, within the P2 protocol, you may be asked to collect total ammonia. This bottle is pre-charged, meaning the preservative is already inside the vial. Because of this, do not fill it directly in the lake, as the preservative could contaminate the water. You will fill it using water from the Chlorophyll A bottle, which we will describe in a few seconds, and you will pour that into the total ammonia vial. Careful not to overfill the vial, and then place it back into the bubble wrap, remove the tape, seal it, and put it back into your cooler. Regardless of which bottles are provided, you will only fill the brown chlorophyll labeled bottle. You will only fill the brown Chlorophyll A labeled bottle directly in the lake water. This bottle acts as your composite jug, which you can use to pour off into the other bottles. Take care not to overfill, especially for pre-charged bottles. Once the other bottles are filled and preservatives added, make sure the Chlorophyll A bottle is filled up fully so it can be filtered. These bottles also do not need to be triple rinsed, just filled up using the water from the Chlorophyll A bottle. Always refer to your manual for details on how to store your samples properly. Most bottles will be kept in the fridge, but microcystin and Chlorophyll A filters, once completed, should be stored in the freezer until shipment. For P2, samples must be shipped or dropped off within 3 days of collection to ensure they meet laboratory hold times. If you're not filtering the Chlorophyll A yourself, the samples must be returned within 24 hours for an ALMS staff member to complete the filtering. You can review the Chlorophyll A filtering steps later in this video or refer to your field manual. Next, we will filter our chlorophyll sample. So you will put your chlorophyll kit on the table and your chlorophyll bottle, and we will take out all the supplies we need, and we will open our bottle so that we can pour the pure water into that bottle that we will use for rinsing later. Then we can clear off our cooler so we have some space on the table. And we will take out our bag that will have our gloves in, and you will want to put your gloves on so you don't contaminate the sample. And we will attach the hand pump hose to the filter apparatus, and we will take everything out of the bag just so then it's accessible. And we will take 3 petri dishes out of the bag because we will use those for our filter samples. And we will unscrew the top of our filter apparatus, and we will grab our tweezers, and we will place one of the filters that we have provided. We'll place that onto our filter apparatus, making sure it is nice and centered, and make sure you just grab one. Sometimes they kind of stick together, so you might just have to pry it apart a little bit so you don't rip the filter. And then we will put the lid back on the filter apparatus. Then make sure that you turn off the light. The less light shining on the chlorophyll sample, the better. It won't degrade as quickly. We will take our chlorophyll bottle and we will invert it 4 to 5 times just to make sure that everything has been mixed and nothing is settling on the bottom. And we will pour a portion into our graduated cylinder. Start with a little bit at first, and you will jot down the number that you filled the graduated cylinder to. So in this case, we measured 48 mils for this first bit. And we will open up the top. We will use the pure water to wet the filter paper and hand pump it a little bit. Then we will pour that 48 milliliters into the apparatus and hand pump it so that it pours through the apparatus. Then we will take the top off, and we're going to check and see if there is any hint of color. It is a little hard to see in this photo, but we want to see just a hint of color, and you may have to take the filter paper off and kind of twist it around just to see if there is. The filter paper might have different colors on it, as seen in these pictures. You can have different kinds of cyanobacteria, so just to note down the color and write it on your field sheet. If there isn't any hint of color, we will put it back on the apparatus. and we will measure out a bit more, about another 50 mils, and pour that in and hand pump it again. Once the water is through, we'll check again to see if there is any color on the filter paper. So again, we will take it off because it's a little tough to see sometimes. And we can see, it's still a little bit hard to tell, but there is color on the filter paper. So we will continue on to preserve the filter paper. But if you still don't see anything, you will just repeat the process again. Just make sure that you do not filter more than 300 mils, and also jot down the number on your field sheet and the color of the filter paper. We will then rinse our graduated cylinder and pour that onto our filter paper, and we rinse it 3 times. And then we will rinse the sides of the filter apparatus 3 times as well, trying to get anything that might have been left over or stuck to the sides, and hand pump it through. Once we've done this, we will go into our little baggie where there is magnesium carbonate, MgCO3, and we'll open that up and take our dropper, and we will take a little grab of that, and we will put about 4 or 5 drops onto the filter paper. Place the cap back on the magnesium carbonate and put the dropper and the bottle back into the sandwich bag. And again, hand pump just to make sure all the moisture has been sucked through. We will take the lid off, and we will take our tweezers and we will fold the filter paper in half and then in half again so that we have it in quarters. And we will take our petri dish and open it, and we will put the filter paper in the petri dish, and we will wrap the petri dish in tin foil. This will keep it from being exposed to any light, so then it's easy for transport. Then we will take our labels and we will fill out the label. Like our bottle labels, we will put the lake name, the location name, the date, and we will put the amount that we filtered. So we'll refer back to what we wrote on our field sheet. So for this amount, it was 98 mils. And we will take that label off and put it right onto the tin foil that we wrapped around our petri dish. And that is it for that first petri dish. And we'll put it in the Ziploc bag so that it doesn't get wet during travel. And then we will repeat the process 2 more times so that we have 3 different filter papers in 3 different petri dishes. We will repeat this process, but keep an eye on the bottom part of the apparatus that is filled with water. If it's full, you will want to detach it from the top piece, and you never want to pour this down the drain so we can avoid any spread of any possible invasive species. Since you will be near the watershed that you are collecting the sample, you can pour the water back outside and that will work just fine. We will put those filter samples in our freezer to keep them frozen until we can ship them back to the ALMS office. We will now go over the shipping protocols. Before shipping, always make sure you've included all your samples, including your microcystin and chlorophyll filter stored in the freezer if your protocol calls for them. Please include a copy of your field sheet inside the cooler. To keep it dry, place it in a Ziploc bag before adding it to your samples. Always include a couple of frozen ice packs to ensure your samples stay cold during transport back to our office. Once your cooler is fully packed, tape it shut securely to prevent anything from falling out. ALMS staff will have already set up Purolator return labels for your equipment. These labels can be found in your probe kit and will either be for the entire sampling season or for individual sampling rounds, depending on your setup. Each sample will be identified for you, indicating whether it's for the probe kit, filter kit, or sample cooler, and will have a specific weight assigned. Make sure to attach each label to the correct piece of equipment when shipping back. Put the appropriate labels into the provided sleeve, with the barcode facing out and visible. Tear off the tape and fold the top part over to secure the label in the sleeve. Press it to the top of the cooler and make it secure. If you're keeping your equipment for the full season, only attach the sample cooler return label and send it back to us. You can hold on to the chlorophyll filter and probe kit until your last round of sampling. On your final round, you will return everything together, your samples, probe kit, and chlorophyll filter kit. Your cooler is then ready to be dropped off at your nearest Purolator location. You can find a map of nearby locations in your field manual. Finally, please notify the program coordinator once your samples have been shipped. So there's a couple things that you will want to note before you decide on a date to sample. So make sure that you don't sample on a Thursday unless you are able to drop the samples back off at our office the same day. Also, please do not ship samples out or complete sampling on Fridays or Saturdays, as our office is closed over the weekends. The field manual will list stat holidays that our office will also be closed. Please refer to that. Also, please refer to the Purolator location and cutoff times in your field manual's appendix, and to send us a picture of the tracking number so we can keep an eye on the shipment. As you head out into the field, always refer to your field manual provided in your probe kit for the most up-to-date bottle sets and sampling protocols. It's your best resource for ensuring that your sampling is accurate and consistent. And remember, if you ever have any questions, run into issues, or just need a little troubleshooting support, don't hesitate to reach out to us. We are here to help. You can reach us at our email, lakekeepers@alms.ca, or you can call our office at 780-702-2567. From all of us at ALMS, thank you for your participation and continued support. Without your efforts, we wouldn't be able to build such a robust and meaningful data set on Alberta lakes or advocate for their health and protection. Happy sampling and enjoy your winter out on the lake.